Happy morning, children. I am your physical science teacher. Hope you are all safe. First of all, I should congratulate all of you for successfully completed your October monthly test. Next, we will concentrate on our November monthly test. For that, you have only one lesson in physics, Unit 3, Thermal Physics. In this lesson, we are going to learn what is heat and temperature and the absolute scale of temperature, then thermal energy and the thermal equilibrium. Next, the classification of expansion of substances, then fundamental laws of gases, and distinguish between the real gas and ideal gas. Next, the important one is derive the ideal gas equation. All these things you are going to learn in this lesson. Children, watch this video carefully and understand the concept. Assignment is given in the PDF. You write only the question answers, short answers and the detailed answer. No need to write the 1 marks in your classwork. Introduction. Sun is the primary source of thermal energy for all the living organisms. Thermal energy is the cause and the temperature is the effect. All living organisms need a particular temperature for their survival. In the kitchen, a container with a steel bottom is placed on the induction stove. Do you know why? All of us have a common man's understanding what thermal energy and the temperature. But in this chapter, we shall learn about thermal energy and temperature in a scientific manner. We shall also discuss about how thermal energy is transferred and the effects of thermal energy. Now you can see if you take any object at 100 degrees centigrade, it is in the hotness, that is also called as temperature, or you can take another one object for coldness 0 degrees centigrade, that is also called as the temperature. This is the simple definition for temperature. Is defined as the hotness or the coldness of the body. The real definition is the temperature is defined as the average kinetic energy of the molecules. What is this kinetic? Kinetic energy is the movement. Now you can see this images. First one. Now you can see these images. First one, on heating more this pan, what will happen in the solid inside the minute molecules? It starts vibrating. On heating more, it will start vibrate more. So you can see the second picture. If you touch with this with your hand, what will happen? On vibration is more in this pan. When you touch with your hand, what will happen means the cells will damage. You can see in this third picture. Okay, so this is the definition. Average kinetic energy of the molecules. The molecules are in the movement. Next one we see temperature is defined as the degree of hardness of the body. You can see the temperature is higher for a hotter body than for a colder body. This temperature is always higher for a hotter body than colder body. Okay. Next up, It is also be defined as the property which determines whether a body is in equilibrium or not with the surroundings. Here you can see the molecules are in random motions, are moving here and there. Further, temperature is the property which determines the direction of flow of heat. Which determines the direction of flow of heat. It is a scalar quantity. You can see this diagram. This is a coffee. Surrounding is a Here you can see this diagram. A cup of hot coffee is there. The surrounding is a cooler. So we know that heat is always a transfer from hotter body to the cooler cold body. Hotter body to the cold body. You can see here. Okay. In this second diagram, the surrounding it is a warmer. The surrounding it is a warmer. Here you can take ice cube. So it is a cold object. So heat is transferred from hot body. You can see this arrow from hot body to the cold body. Okay. So heat is the flow of energy from a light temperature location to a low temperature location. Next one is the absolute scale or otherwise Kelvin scale of temperature. Okay, the temperature measured in relation to absolute zero using the Kelvin scale is also known as absolute temperature. It is also known as the thermodynamic temperature. Here, thermodynamic temperature. Thermo means what? A heat. Dynamic means the temperature is varying. It will not be stable at any constant temperature. It is varying. Okay. So absolute is zero. You can see this Fahrenheit, Celsius scale, and is the last one is the Kelvin scale is given. First one, if you take a Fahrenheit, absolute is zero. For Fahrenheit, the thermometer absolute 0, 400 minus 459 Fahrenheit. Water freezes at 32 degree Fahrenheit. Water boils at 212 Fahrenheit. In Celsius scale, minus 273 degrees centigrade, absolute zero, and the water freezes at 0 degrees centigrade, and the water boils at for Celsius scale 100 degree Celsius. In Kelvin scale, absolute zero, 0 Kelvin, water freezes at 273 Kelvin, water boils at 373 Kelvin. This is the thermometer's comparison between Fahrenheit, Celsius and the Kelvin scale. Okay. Next, for each unit of the thermodynamic scale of thermometer temperature is defined as the fraction of is defined as the fraction of 1 by 273.16 part of the thermodynamic temperature of the triple point of water. Temperature of the triple point of water. You can see this diagram. The temperature and the pressure are at the point where all the three phases, gaseous, liquid and the solids of that substance coexist in this thermodynamic equilibrium. So if you observe, water is melting, freezing and boiling at the same time. Next. measuring of a temperature. So it is a scalar quantity. SI unit of temperature is Kelvin. It is denoted by the letter K. The other commonly used units are Celsius, is denoted by the symbol C, and the Fahrenheit symbol F. You can see this. First one is the Fahrenheit, second one is the Celsius, and the third one is the Kelvin. The units for Fahrenheit, the freezing at water 32 degree Fahrenheit, for the boiling point at 212 degree Fahrenheit. For Celsius scale, water freezing at 0 degree centigrade, water boils at 100 degree centigrade. For Kelvin scale, the water freezing water at 273 Kelvin, water boils at 373 Kelvin. Okay, so if you want to calculate the K, what is the formula? K is equal to Kelvin. K is equal to C plus 273. If you want to find out C, means C Celsius is equal to 5 by 9 into F minus 32. For calculating F is equal to 9 by 5 into C plus 32. This is the formula to find out K, C and the F. Next, the temperature difference of 1 degree Celsius. The temperature difference of 1 degree Celsius is equal to that of 1 Kelvin. 0 Kelvin is the absolute scale of temperature of the body. You can see here for Celsius minus 273 degrees Celsius, here 0 degrees Celsius, next one 37 degrees Celsius, and the last 100 degree Celsius. The water boils at the 100 degree Celsius. For Fahrenheit, absolute, say 4 minus 459.7 degree Fahrenheit. Water freezes at, for Fahrenheit, 32 degree Fahrenheit. For normal human body temperature, 98.6 Fahrenheit. Water boils at the 212. For Kelvin scale, absolute 0, 0 Kelvin, water freezes at 273 Kelvin. Normal human body temperature 310 Kelvin, water boils at this 373 Kelvin. Next, this is the formula, the relation between the different types of scales of temperature. Celsius and the Kelvin. K is equal to C plus 273. Fahrenheit and the Kelvin. K is equal to F plus 460 into 5 by 9. So this is the important. 0 Kelvin is equal to minus 273 degree Celsius. Next one is the thermal equilibrium. What is thermal equilibrium? Two or more physical systems or bodies are said to be in thermal equilibrium. Thermal equilibrium means what? Equilibrium means equal. If there is no net flow of thermal energy between the system. You can see this diagram. If you take two or more physical system, if you take two systems, one is the hot system and the one is the cold system. So we know that heat is always transferred from higher temperature to the colder temperature. Okay, see here, higher temperature 100 degree Celsius is there, for cold 0 degree Celsius. So after heating, what will happen? Here in this first condition, the temperature is decreasing up to 50 degrees centigrade. In the second condition, 0 degree is raising. After heating, it is raising, increasing the temperature up to 50 degree Celsius. So finally both will be equal. So after heating, this two system or these two bodies are said to be in thermal equilibrium. So after attaining this equal value, there is no net flow. After that, there is no net flow of thermal energy between the system. Next, heat energy always flow from one body to the another body due to a temperature difference between them. So we can define thermal equilibrium in another way. If two bodies are said to be in thermal equilibrium, then they will be at same temperature. They will be at same temperature. Here you can see three system, system A, system B and system C. First you take system A and system C. If the temperature is more in system A and the temperature is less in system C, so what will happen? It transfer from higher temperature to lower temperature. So system A and system C are in thermal equilibrium. Next, second condition, B and C. You can take system B and system C. Here system B is more temperature and system C is less temperature. What will happen after heating? Uh, Heat is transferring from highest body to the higher temperature to the lower temperature. So after attaining this, B and C are in the thermal equilibrium. Then the third condition, system A and B are also in the thermal equilibrium with each other. Next, what will happen if two bodies at different temperature? Two bodies at different temperature are brought in contact with one another. Two bodies எடுத்துக்கிறோம் at different temperature, வேற temperature என்ன பண்றோம் பக்கத்துல வைக்கும்போது there will be a transfer of there will be a transfer of heat energy from end body to from hot body to the cold body. Heat energy transfer ஆகுது எது வரைக்கும் until a thermal equilibrium is established between them. ரெண்டும் equal ஆகுற வரைக்கும் அது என்ன ஆயிட்டு இருக்கு? You can see first you can take system A 10 degrees Celsius, system B 20 degrees Celsius, and the after heating the heat is exchanged. System A 10 degrees centigrade and the system B 20 degrees centigrade. If the heat is exchanged, what will happen? This 20 degrees centigrade, the heat is always transferred from higher temperature to lower temperature. So this 10 degree becomes 15 degree centigrade. So here in this condition heat is increasing. Here in the system B, here also the heat temperature is decreased from 20 degree to 15 degree. Finally what will happen? System A and the system B will attain the same temperature. So this is called as the thermal equilibrium. Next, when a cold body is placed in contact with the hot body, some thermal energy is transferred from hot body to the cold body. As a result, some rise in the temperature of the cold body and decrease in the temperature of the hard body. This process will continue. This process will continue. இது வரைக்கும் பார்த்தீங்கன்னா until these two bodies attain the same temperature. ரெண்டுமே சேம் டெம்பரேச்சர் வர வரைக்கும் என்ன ஆகும், இந்த ப்ராசஸ் வந்து கண்டினியூ ஆகிட்டே இருக்கும். ஓகே, next one is the thermal energy. We know that thermal means heat, so heat energy. When a hot body is in contact with another cold body, a form of energy flows from the hot body to the cold body. This is known as thermal energy. So heat transfer. This is a warmer object. Heat is transferring from hotter body to the colder body. So it is also known as heat energy or simply heat. Next one is heating. What is heating? The process in which heat energy flows from a body at higher temperature. Higher temperature to another object at lower temperature. Higher temperature lower temperature is known as heating. Transfer of heat. The transfer of heat may be of any of these ways, like first one, conduction, convection and radiation. You can see this images for conduction. If you touch this fan, physical contact is the conduction. Next, second one is the convection. Water cools, became more dense in the skins. Hot, less dense water rises. You can see here. And the second one, the last one is the radiation. From the sun, it radiates the rays. It reaches the earth. This is the three ways: conduction, convection, and the last one is the radiation. Next, characteristic features of heat energy transfer. First one, heat always flows from a system at in the temperature at higher temperature to a system at lower temperature. Higher temperature lower temperature heat flow. This is the first point. And the second point, the mass of the system is not altered when it is heated or cooled. Okay. Third one, for any exchange of heat gained by the cold system is equal to the heat lost by the hot system. So finally, heat gained is equal to heat lost. Heat gained is equal to heat lost. We'll see here. So higher temperature lower temperature போது அதோட mass வந்து என்ன ஆகாது, மாறாது. Second point. Third point என்ன சொல்றாங்க, heat gained is equal to heat lost. 52 beaker. So 100 degrees centigrade, 50 degrees centigrade. What will happen? It will, from this first beaker, so from this first beaker, heat is transferring from higher temperature to the lower temperature. So first one, it becomes a 75 degrees centigrade, means the second will also become 75 degree. So after that, finally it will become equal. It attains thermal equilibrium. So எந்த அளவுக்கு heat gain ஆகுதோ அதே அளவுக்கு heat வந்து loss ஆகும். Both are equal. Next we will see the units of heat energy. The SI unit of heat energy is joule. There are some other commonly used units are calorie. One calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water, 1 gram of water through 1 degree centigrade. Next one is the kilocalorie. 1 kilocalorie is defined as the amount of heat energy required to raise the temperature of 1 kilogram of water through 1 degree centigrade. This is the scientist named Joule. So you can see here for kilocalorie, 1 gram of water at 1 degree through 1 degree centigrade. For this kilogram raises the temperature of 1 kilogram of water through 1 degree centigrade. Next one is thermal equilibrium. So two or more physical systems or the body is said to be in the thermal equilibrium if there is no net flow of thermal energy between the system. You can see this first diagram. The temperature is more, second one the temperature is less. After what will happen? If the heat is transferring, both will attain the same level. So hot body to the cold body, it attains the same temperature, 26 degrees centigrade, 26 degrees centigrade. Effect of heat energy. The temperature of the substance raises. The temperature of the substance rises. The substance may change its state from solid to liquid or from liquid to gas. The substance will expand when heated. You can see this pictures. First one, if you heat the water, what will happen? The temperature of the substance is raises. Second thing, the substance may change its state from solid. This is the solid, ice, and the liquid. After it melts, it becomes a liquid water. After that, it becomes gaseous water vapor. So it changes from solid to liquid or from liquid to gaseous state. The third condition, the substance will expand. For any substance, when heated, it will expand. Next, expansion of substance. You can see here clearly. When a heat energy is supplied to your body, heat பண்ணும்போது that can be an ஏதோ ஒரு சப்ஸ்டன்ஸ் நம்ம என்ன பண்றோம் ஹீட் பண்ணும்போது அங்கே என்ன நடக்குதுன்னா அந்த சப்ஸ்டன்ஸ் வந்து ஸ்மால் இன்க்ரீஸ் இன் தி டைமென்ஷன் ஆஃப் த ஆப்ஜெக்ட் வந்து கொஞ்சம் இன்க்ரீஸ் ஆகும். திஸ் சேஞ்ச் in the dimension due to ஏன் பார்த்தீங்கன்னா raising temperature அதிகமாகிறதுனால is called thermal expansion of the object is called thermal expansion of the object. All the forms of matter undergo expansion of heating. You can see this picture. Due to increase in temperature, the mud gets expanded. Second one, see the thermometer inside the mercury is there, no? So if you mercury gets expanded due to increase in temperature. Third one, what happens when a gas expands? You can see this.